Welcome back, ladies and gentlemen. Continuing our exploration of chapter 18, which is derivatives of carboxylic acid. We left off by doing this activity the other day, thionyl chloride with a carboxylic acid to make and we didn't even say it, an acid halide. I may have said it without writing it, but we're writing it today. So today, later in activity 2, you're going to learn how to name acid halides. And here we're learning how to use acid halides because all of the next reactions have an acid halide as the reactant. They're very versatile. They're very reactive. So I want to do them all at the same time. I know sometimes I can drive you a little crazy, but I just want you to see they start off the same, every one of them. So same 2 arrows for every one of them. I'm going to cross off a spectator where there is one. I think this is the only spot. I do want to point out that that's a nucleophile, right? But it's not an exceptional nucleophile, not a strong one, because it's resonating. And it's strong enough because acid halides are very reactive. So are you surprised we attack the carbonyl and break the pi? I think we've been doing that already. Alcohol, nothing to cross off. Attack the carbonyl, break the pi. Amine, this is probably just a lot faster, this one. You want to do speed on the left? Relative speed, just for fun. Alcohol is going to be real slow. I'll call that like 1. And how many times faster do you think a moderate nucleophile would be, which is the top one and the bottom one? They're both moderate. Would you think it's like twice as fast? Go bigger. I'm just going to crude estimate here. 10 times faster. That's all it says. I won't put it on your test. But you should be able to tell me which one's the slowest. It's the one with the worst nucleophile, right? The middle one. That's what I want to hear from you. Now, you can probably guess the second step. You've just generated an O-, right? Which can resonate back and kick off a pretty darn good leaving group, right? Cl-. So we're going to do the old red first, blue, green second. So slap a lone pair up on each of the O's. Have the green come back and kick off your LG. Coming back, kicking off LG. Coming back, kicking off LG. We're almost there for every one of them. Almost finished. Wait, first one we are finished. Wow, I love it. We got some cleaning up to do after the second one and the third one. And what we have is isopropyl goes to carbonyl. Not very well drawn, but you get your O with your H plus. And Cl-. And you got that. And down here you got, here we go. Carbonyl's back. There you go. Plus Cl-. I know a lot of you want to use the Cl- to finish this off, right? I don't object terribly. I really don't, but I do want you to realize to make this reaction go really well, they use ethanol as the solvent for the middle one, and they use ethylamine as the solvent for the bottom one. I'm trying to say there's a lot of those molecules around. The ones over the arrow, I'd prefer you use those as the base. They're a little stronger base, and the amines a lot stronger base, so I really prefer that one. So alcohol is your base, please. I will forgive you if this one you forget and you use the Cl minus, but I will not forgive you for the amine. Won't forgive you for this one, because that's a lot stronger base. And just have it come in and do its thing. Acid base, end of story. There's the end of story right there. There you have it. Sorry? And I'd have to call the second one alcoholysis, and this one aminolysis. Can you describe those words to me? I broke it apart using what? In the first, this middle one here, an alcohol broke it apart. The Cl minus came off, the alcohol ended up attached. And the amine broke it apart here. Cl minus came off, and there's an amine on there now. And talk to me about the functional groups we made, because we started with an acid halide in each one. Let's get some fancy pens going. We don't use them enough. I like that one there. Acid halide became what in the top one? Maybe you don't know yet, because we just started this chapter. That's called an acid anhydride. Wow. It has two acids together and water got lost. If you look at the structure. Just trying to explain that name here. This is no chemistry. This is just trying to explain the name. Here's two acids. Do you agree those are two acids? The blue, if you combine the blue and take it out, what do you got? H2O, that's called water. So what do you got to do to make these two things into this thing in terms of just looking at the structure? Remove water from the two acids. That's a perfect name then. Remove water from the two acids and glue together what's left. Isn't that what this is? It's an acid anhydride. It's got a good name. I can get behind some names. That's one of them. Okay. And what about this guy over here? That's one we have seen already. It's an ester. And yes, you're allowed to use the word ester by itself if it's a carboxylic ester. So I'm glad, because I don't have a lot of room here. And what about this guy down here? What is this? Okay, it's an amide. I need a little more. This one here happens to be secondary, doesn't it? So just to keep things straight, pen, we don't use the yellow, but I think it's good for this. There you go. So that's three of our functional groups, and that's our activity. And I will do a trade with you for a new activity.